Octavian Guzu, CTF enthusiast and ECSC team leader and software engineer at Bitdefender, is here to tell us all about his experience at the European Cybersecurity Challenge of 2018. So, Octavian, I'm really looking forward to hearing how the entire experience was for you. And, maybe we'll find some new contestants for next year as well. Let's give it up for Octavian.
Hi everyone, how's the day going? So my name is Octav. I'll be talking about my experience at the European Cybersecurity Challenge, or ECSC for short. I'll be covering more than just the contest. I'll be covering the whole experience that I've been through during the online round, the bootcamp, and the finals in London this year. So let's get it going. Some short description about me. I'm a fourth year student at the University Polytechnica of Bucharest. I'm a software engineer, part-time at the moment, and I'm a CTF enthusiast. That is, I take part in CTFs in my spare time, and I find them really challenging, and I'll be showing you at the end of the presentation in some short demos about what it means to take part in a CTF. Also, I was the captain of the Romanian team at the European Cybersecurity Challenge this year. And as I said, I will talk about what it meant for me. Also, you can find me on Twitter or on email on these addresses. Okay, so a short introduction in security. Has anybody had this message on your phones at the end of October, I believe? Hands up. Okay, so for those who don't know what this was, it was a huge data breach from Facebook. They somehow messed up their access tokens and they leaked 30 million users. For some of them, 15 million, they leaked usernames and contact information. And for 14 millions, they leaked almost all details that were listed in the profile page. So sensitive information like some personal details that are normally hidden from the a user just browsing their profile. Okay, anyone has an idea about what security incident I'm going to talk about seeing only this image? Hands up. Okay, so if you don't know, that is a Tesla Model S, and some researchers were able to hack a Model S by cloning the key fob in 1.6 seconds. How they did that? Actually, they found a method by getting really close to the owner's key and then getting really close to the car, and they were able to do some kind of simple brute force on an 8-bit number, and they could just simply make another key in 1.6 seconds. So they were able to just make another key and just drive the car, no alarm or security signals detected. And the fun part, yeah, they got a lot of money for it. And in general, security researchers will get some money in the form of a bounty from big companies that encourages them to do such sort of bug bountying on their software, because at the end of the day, they will just improve their software, right? Okay, so for someone that wants to get involved in cybersecurity, there are a lot of fields you can do this in. You can do network security, where you are investigating the security on a network, or you are securing a network for a client, for instance. You can do application security, where you get into examining applications and how safe they are. You can do mobile security, working on this kind of endpoints, devices, and it's a really cool area. You can do malware analysis, which are a huge thing these days, because there's a lot of malware going over the internet and a lot of people are opening random stuff. So security experts in this field are essential. You could do security auditing. That is, for a company, you just analyze the software that they're running and give them a report at the end of the day. Okay, so for someone that has no idea about how to get involved in this type of field, well, there's a lot of things you can do. You can be part of a community, say Slack or IRC. You can join academic institutions, university or schools. Some schools, even in Bucharest, will teach you such type of security. You can go to training, conferences, certifications, but that's really will cost you a lot of money. And the best thing, in my opinion, is to take part in Capture the Flag events. Yay. Okay, so what is a Capture the Flag event? Has anyone here heard about the Capture the Flag event? Hands up. Okay, lots of people, that's great. For some of you that have little experience with web security, this web page may seem more than a login page. For instance, for me, when I look at any login page, I don't think, I don't see it as a regular login form. I think about SQL injection or say any kind of vulnerability that you may be finding within that login page. So what I see is that enthusiasts and security enthusiasts will always have that feeling to just go and try some quotes or some dots here and maybe see if the login form will check, yeah? So as I said, there are educational challenges, the Capture the Flag events, where you get vulnerable applications that are left intentionally vulnerable by their designers, and you have to get the vulnerability, exploit it, and get the flag. The flag is usually a plain text message, and it's a proof that you solve the task. And you submit flags, and you get points, and the scoring system is based on how difficult the task is. Say, easy task will be 100 points, and a harder task will be 500 points. And it's really worth trying difficult tasks because you get a lot of points from them. The main website for finding CTFs is ctftime.org. There are listed any upcoming CTFs or CTFs that happened in the past, and you can see write-ups on the tasks that were given there because you can learn a lot from write-ups. Okay, so the main subject for today, the European Cybersecurity Challenge. How it happens, it's an European CTF. It merges a lot of countries from Europe, and each country will have a team of 10 people, in which 5 of them are juniors, between 16 and 20 years old, and 5 of them are seniors, 21 to 25 years old. And the finals are held in different locations each year. This year, finals was held in London. Next year, they will be held in Romania. So a reason for you to join them next year. The official website is this one, but you'll get the slides. You can visit it if you're interested. Okay, so how does the ECSC happen in Romania? So there are multiple steps for a contestant if he wants to get to the final round. There will be an online qualification round where first 15 juniors and 15 seniors will go into the boot camp. And at the end of the boot camp, the final team is selected. That is the 5 juniors and 5 seniors that are going to be representing the Romanian team at the finals. And everything is covered. So all expenses are covered, and it's a really cool experience for you to go and learn something new. Even if you don't make it in the final team, you can just join again next year and maybe make it then. So what I want to show in this picture, in the online qualification round, you get certain different tasks depending on the field that they're related to. So you can be solving programming, exploit tasks, web tasks, and so on. So if you're good on web, you can just solve the web tasks. And the points are made in such way that if you solve most of the web tasks and some easy tasks from the other fields, you will make it into the bootcamp. So you don't have to be an expert in all of them. You can just be an expert in one of them and solve some easy tasks on the side, and you will make it into the bootcamp. These are the scoreboards from the junior and the scoreboard and the senior scoreboard this year. Sorry. Okay, so the bootcamp happens here. Anyone knows where this is? Hands up. Okay, the bootcamp is always held in Bran, where you get 1 week of trainings and CTFs, which for me was very educative. We had an expert on each day from different companies, and they were coming to give us some talks on different fields that will be helping us in the finals. So one day we were talking about binary exploiting. The other day we were talking about web exploits and so on. So each day a different person will be coming in the bootcamp to talk to you about what they know best. So yeah, as I said, forensics, exploits, web, and so on each day. Okay, some pictures of the main room where we were training. The room was gathering us all, and we were living close to midnight each day because we were really enjoying working together, and the fun part it gives us staying there is really cool. But you don't only have to learn, yeah, because if you just study day by day, you will not get anywhere. And we also went to paintball as a fun activity. And the most fun activity, we played CS on the local network. Okay. The finals. So, as I said, the finals were held in London. No need to ask where this is. We stayed at the London Tower Hotel, and the contest was in another place in the dock. There were 20 countries, and the CTF was a two-day CTF. So the points would add up. The points from the first day with the points from the second day would add up, and the team that scores the most overall points will be winning the finals. And you get lots of challenges because they outsource challenges from lots of companies. So there are usually more challenges than you can solve. So you should know how to divide your team into solving the challenges that are worth more and are worth investing your time into them, because you play 8 hours a day and 8 hours the other day, so you get a total of 16 hours for the challenges, and the challenges are a lot more than 16 hours. So you should know how to balance those tasks, because if you waste a lot of time on a very difficult task that you are not really sure whether you can solve it or not, you may be losing both points and time. One really cool challenge that we had at the finals was the hardware hacking. We were given an Arduino Nano device, and we knew that it has a login form running on it. So one may say, okay, this is pretty easy. We just connect to the RX and TX pins on it, and we get the binary. Where it was not that easy because the organizers were not using the default pins for this, so we had to just try all the possible pairs on all the pins on the board, and just try to send this something, wait for a response, no response, move one pin, send something, wait for a response, and so on. So we finally got the RX pins, RX and TX pins, and we were able to dump the binary file that was running onto the Arduino Nano. Okay, from then we dumped it, and we used obj copy to get the binary from the hex file. From now on, you should decompile it and try to understand it, right? But we just used strings. So this is how the hex file looks, just a bunch of addresses and then some hex data. But after we use strings on it, we get the login info, which is root and password admin, and we also get the flags. So there was no need for us to dynamically run the application. We found all the information we needed inside the hex dump. We also had an escape room challenge at the finals. 4 of us got involved in some kind of small round room where we had 5 main challenges. The first one was actually to hack the entrance somehow. So there was a code at the entrance, and we had some hints. So we were able to hack into the room. In the room, I don't have images there, but there was some sort of box that they called it a bomb. So we had to somehow stop the bomb from exploding, and it was a combination of lockpicking, some electronics. We almost got it to stop it, but we lacked about 15 to 1 minute, say, time for us to stop the bomb, so we didn't actually manage to stop it completely, but we got some pressure points on the way. Really cool experience. Okay, so I'll be doing some demos on the tasks that we had both in the bootcamp and in the final, so you can get a general idea of how things are happening at these types of contests. This one's working. Great. Okay, so I'm starting with the first task. Its name is dumpster. And what we get from the task description, we get a file, dumpster.jpg. So from the extension, it should be an image, and we try to open it, but it doesn't show up. So there must be something wrong with the image. So what I did, let me just move over to Kali. I looked into the hex dump of the image. So dumpster. Okay, so the first bytes are 8B, AC, and 8B. So I don't know yet whether they are valid bytes, so I'll just Google it. JPEG header. Okay, so on the first website, I can see that the first bytes in a JPEG file should be FFD8FF. While in my case, there are 8B, AC, 8B. So clearly there's something wrong about this picture. We get a hint that it should be a picture because of the extension that the organizers gave us, but it's not really showing up as a valid picture because of the header. But what we see is that the first byte and the third byte are the same, which is the same in a valid JPEG image, because the first and the third byte are FF, both FF. So what I'm thinking at this point is that maybe the image was stored with some sort of a 1-byte key. So in this case, if you store each byte with a certain key, it's obvious that the first and the third byte will give the same value after the XOR operation, because the XOR key is one key. So how do we check if this matches? So we'll just store some numbers online. So I said that the valid first byte would be FF, and the byte that we have is 8B. So we XOR them together and we get 74 in hexa. Okay, so this is for the first byte. Let's check out the second byte, D8, which should be the valid byte, and the byte that we get is AC. So we XOR them and we get the same number. So we see some kind of pattern at this moment. So one may think, okay, why not try XORing all the bytes in the file that we have now with 74? And this is exactly what I did. So in this Python script, I'm just XORing each byte of the image with 74, and I will be printing the output in a new image called XOR.jpg. So let's run it. Okay, it runs, and let's check what we got. So we got an image. Okay, this is pretty cool, but remember our goal is to get the flag. There's no flag here, so we have to move on. When we see a picture, the main thought is maybe there's something hidden in it, because a lot of guys enjoy hidden some sort of files or some plain text or all other stuff inside of images. So if you want to look into an image for other files, you can use binwalk. And binwalk will extract the other files that it may find within the okay, this is odd. Okay, so it says that it find the JZip data compressed. Okay, that might be something. Let's look into it. So we can open it with 7-zip because we know it's an archive, and we get a file, flags in a trash can. Okay, this is an ODS file. It's a pretty odd extension, right? But just open it and see whether we get something from it. it looks empty. And it is empty. So what I did, I tried the same thing again. I thought maybe someone was hiding something within the file that was being hidden inside the image. So I just run binwalk on it again. 0. So run binwalk on the file that we just got and let it run. And what do we get? We get a lot of files from it. So we know that the flag should have a format, because that's how you usually find flags within an application. So what I did, I tried to search the entire folder, find in folder. So I was searching for the string that I cared about, it as ECSC and a bracket, because that's how flags begin. Okay, so it found something, and down here we get the flag. And we submit it, and we get the points. Okay, great. Next task. Okay, in this task we get an image. The task is called broken CTF, and the image is called a broken TV. We look into it, we get some random noise. So there must be a flag somewhere inside, because that's the only file that we get, but it's not really obvious at this moment how we should approach it. So what I did, because those pixels seemed pretty interesting to me, especially because of the first pixels on the first line that seem similar. Some files have a tendency to have similar bytes in the header, so I was thinking maybe there is an actual file that is been inserted into the bytes of the image. So what I did was I opened the image in a Python script, and I started to display the first bytes of the image. So we run this, and we get these are the first bytes in the image. So it's not the header of the file; it's the actual data within the image. So the first number is 137, second one is 80, 78, and so on. So let's just Google this. So 137, 80, 78, 71. Okay, PNG. Things are starting to look well, right? 13, 10, 26. 13, 10, 26. Okay, so it seems like there is an image that's being hidden within an image, but in its actual image bytes, so in the pixels of the image. So the next step is pretty obvious. We just dump the pixels into another file, so we should get another image. So I run the second script, and it creates an image, and inside the image we get the flag. We submit it and we get the points. Okay, since we have time, I'll show you an Android task. So I will actually be showing you how I solved this task. Usually in CTFs there's not a certain way that you should be doing a task. The goal is to get the flag. If you manage to get the flag in one way or another, then good for you, you solved it. So you can count it as solved, even though you didn't use the method that was intended by the organizers. So we get an APK, which is an Android app, and there is a really cool tool in Linux. You can use APK tool to decompile an Android app. So let's just decompile the app with APK tool. D for decompile and the app we want to decompile. And it will give us some pseudo JVM code. It's not actual Java machine code. It's just some pseudo code that we can understand maybe what the app is doing. So inside the app, there were a couple of main things that we had to do. We had to find an username and an admin. If we would run the app inside an Android emulator, a login prompt will appear. So we need to get the username, the password, and a secret flag that was inside the app. I solved this task statically, so I didn't even run the app, and I will show you how I did it. So the APK tool will create a folder, cyber in this case, and we just open it. It should have opened. Okay. So within the files, I will just go directly into the decompiled app. And the main activity that we should be looking in is the main activity. And from this on, you just start investigating stuff like maybe you can find some interesting data within the file. So what I did, first thing, search for a password. No password, go into the second main activity, search for a password. Okay, we get a password. Look around, username, password again. Okay, this looks good. We get a username and a password string, but they have no values yet. So we scroll down. This looks like base64, right? Then we get another string that looks like base64. So this may be some relevant information. Let's just decode it. So we echo it. And base64 decode it, right? So we get something that looks like a username. Well, it actually is the username of the app. And if we decode the password, or what we may think is the password, we get this. At this point, I was not really sure whether these were the right username and password, but I just submitted them and they worked. So good for us, they worked first time. Okay, what about that secret? So we know there should be a secret around here. So again, let's just search for a secret. Okay, no secret in this file, and searching each file, I got to this file, the hello.smally, and we get a field, my secret words. Okay, this looks relevant, right? So let's just look into it. Okay, we see some base64 again, and what it actually does, it will copy into the secret word the value from another fields, and they are cyber security challenge. So we can get the order into which they are copied into the main secret because of their names. So what we have to do now is to find the cyber security and challenge fields and their actual values that we can put together and get the overall secret. So we are lucky, the last part, the challenge, is directly above it. So we can get the base64 from here and just save it. So this is the challenge. Okay, we get back, we need to find the cyber. So let's just search for cyber in the same file. Okay, no luck. What I did was searching the entire folder for cyber and wait for the result. Okay, here in the registration.smally, at this line we get the cyber field and we get another base64. So this may look like the base64 of cyber. So we save this one as well. So this was cyber, right? Okay, and we are left with the security field. Security. Okay, so we do the same thing for security. And search within the entire folder that APK tool gave us. And inside the strings.xml, we get the base64 for security. So this is security. Okay, just use them together. So it's cyber security challenge. And let's decode this. And maybe we get the secret. Okay, congrats on capturing the flag, cybersecurity challenge 18. So this was the end of the task. We submitted it and got the points. What I'm trying to show you with these tasks, is that not working? Okay, is that in general they get way harder than this. These are some easy tasks that we have to solve during the bootcamp or the finals, but they're pretty fun because you can think of a lot of ways that these tasks may be solved in a different way. So I chose to solve them like this, but someone else may be using another method. And for more advanced tasks where you can exploit a binary and so on, the things are starting to get more interesting. And as I said, they are very fun and educative for you to take part in such events. Okay, so if there are any questions. Okay.
Mike is coming to you in just a second.
Hi.
Hello.
On which place was placed Romania this year? To the
So we had some issues during the first day, and we ended up on the 8th or 9th place, I believe, because during the first day we lost some points on tasks that we had some difficulties in it. On the second day we did great, but we lost points in the first day, and other teams were able to get more points in the first day. So ninth place, I believe.
So it happens that I work for the organization that organized this from ENISA. So I want to ask you if you have any feedback that I can take back. In terms of organization, the platform was developed, let's say, with somebody close to us. The challenges were developed in-house, part of them, and part British Telecom and other sponsors, like you said.
Yeah.
I was also involved in the 2015 edition, and this year was another colleague of mine. And if you can give me feedback, because I have mixed feelings. I've heard some opinions that it was very bad. It was it had a different approach with the contracts and the new style. But maybe if you can give me some feedback on this, so I can take back.
Yeah. So in my opinion, the overall was great. The main challenges were great. What you liked were the flag formats. So we had no flag format that we were searching for. In some cases, we had the flag, but we didn't know how to submit it because there was a string with spaces on it, and some were uppercase, some were lowercase. The submit system was not insensitive, so if you messed up one uppercase or lowercase, then it wouldn't, you wouldn't get the points. There were some problems with the Wi-Fi, but yeah, that was normal because there were a lot of teams that were attacking the Wi-Fi infrastructure. That's really how things happen at this kind of events, and you cannot unfortunately stop this type of issues. But the overall feeling was great. I had a great time at the finals in London.
Okay, we're going to take some question over here as well.
Hi. So you said you don't have to be specialized like through all of the fields, but which one is your favorite?
I enjoy web, although I like to take challenges from other categories. I will mostly focus on web challenges.
Okay.
So you said there are some seniors there. Seniors mean people that participate in the past to this competition, or people that are seniors in fields, like cybersecurity fields?
Okay, none of them. It's just about the age. So for me, it was the first time I was taking part into the contest, and because I was over the age limit for the juniors, I was automatically a senior.
What's the age limit?
So 16 to 20 years for juniors and up to 25 years for seniors.
Okay.
So from 21 to 25. There was a question here.
Yeah, I want to ask you which of the tasks you think was most difficult or interesting or challenging for you?
Within the demos?
Not from the all the contest.
Okay, so I didn't actually looked into each of the tasks because we were a team and we divided tasks. But from the tasks on which I worked, I really enjoyed the hardware hacking because it was different from the main classical challenges. So we had some hardware equipment that we had to hack. I really enjoyed that one.
Something new, always.
We have a question over here as well.
Thank you. You often use, for instance, Google to search for some things. Are there some limitations, or is there some kind of environment you're allowed to use? Or is it just whatever you want?
You can just use whatever you want.
So you can use the internet and everything. How do they restrict the team to the team size of 10? Is it monitored, or they could just ask anybody?
So in theory, you can just ask anybody. They may or may not see this. But if you are doing this, you're ruining the...
Okay, it's just ethics.
Yeah, it's just ethics.
Okay,
yeah. But you can do whatever you want, basically.
Okay. One or two more questions. Over there on the right.
At what age did you start doing this?
1 year and a half. So about 1 year and a half ago, I started doing this type of challenges, CTFs.
Okay, very last question. Anyone else?
There's one in the back there.
Do you know about Cicada?
Sorry?
Please use the mic.
Hi. Do you know about Cicada, the internet mystery?
No?
No, there is this challenge all across the world, and there is a mystery because no one's know who is organizing this, and there are a lot of challenges of this type to decrypt files and from videos and pictures. So maybe it's a good information for everyone.
Okay, didn't know about it.
It does sound like fun. Thank you so much, Octavian, for the presentation, for walking us through the experience.
Thank you.